Okay, in this booklet, it is the most important chapters because we start to talking about the chemical properties of materials. But actually, in the whole syllabus, we will concentrate on four category only. It is the first categories. It is talking about metal. Why we start talking about metal first? Because it is the only category we are talking about the chemical properties of element. Okay. It is a combinations of some common metals. Okay, because there are so many different materials in the world, more than 40 millions. Okay, we need to group them into different groups to study them with similar properties. Metal, because they all tends to lose electrons, they will have similar reactions. Will they have so many reactions? No. Actually, we concentrate on the four reactions of metals only. But not all the metal have the same reactions or the same behavior or the same observation when they react. They have some differences. So we will concentrate on these 2 points: how they react and how the differences they react. Okay. The title of this chapter is called Reactivities of Metal. It is because different metal react differently. Although they have similar reactions, but they react in different rates. That means some will react faster, some will react slower. And when we try to compare their rate of reactions, that means how fast is the reactions. We can group them into or put them into a sequence, which is called reactivity series. That means which metal react faster, which metal react slower. Why we need to put them in such sequence? Because we can estimate which metal will undergo the reaction in which kind of weight. Okay. So why the titles of the reactions or this chapter is called reactivities of metal? Actually, it is the reactions. Actually, four reaction only of metal. So what are the four reactions? Actually, in the following, the syllabus, talking about three of them, including the reaction of metal with oxygen. But sometimes the question may give you information that, how can you write down the equations or give the observations when metal is burned in air? But we know that in air, the most reactive substance is oxygen. And when anything burns in air, most probably it is react with oxygens. Only one exception or two exceptions. Some metal will also react with nitrogen in air, but they are quite not the main reactions. Okay, so be careful when we are talking about reaction in air. It is react with oxygen. Okay, and the second reaction is metal will react with water. Okay, and the third is react with dinyl acid. Dinyl acid. Maybe up to now you don't exactly know what is acid, but in daily life you heard the name acid. For example, in your soft drinks, it contains acid. In your stomach, it contains acid. They are acid, and metal will react with such kind of chemical. Okay, and we will have some brief study of two very common acid. They are dinyl hydrochloric acid and dinyl sulfuric acid. And the second category, well, I have told you that we will divide the materials in the world into four categories and study their chemical reactions. And the second categories, we are talking about the chemical reaction of materials. They are acid and alkali. So next category, when we are talking about the reaction of the material in the world, we will talking about these two acids. Okay, because not all the metal react the same way. Okay, some will react explosively. That means it will give out a lot of gas, give out a lot of heat, and maybe explosions occurred. And some will react slowly. So we need to compare the reaction, the rate of reaction, how fast the reaction is undergo. In order, when we put all the metal in a series, a sequence, according to their reactivities, we can estimate the reactions of different metals. Although we may not have the chance to looking at the real reactions. Some reaction we will never do it in school laboratory. For example, metal will react with acid, but two metal we never put them in acid in school laboratory. They are really explosive. They include potassium and sodium. These two metals, when we put it in acid, immediately, boom. Okay. I will show you in the video, not in our laboratory. Okay. But we can, after we put them in the metal reactivity series, we know, oh, the metal is very reactive. So never put react it with some also reactive substance like acid. Okay. Uh, okay, and the second sentence, tendency of metal to form positive ion. Actually, why we talking about metal when we are talking about the chemical properties of substance, we group metal into same categories because actually more all metals react in the same way. Why they will undergo reaction? Why they will change? Because they all are metals, and metal have the same tendency. They tend to lose electrons and become positive ions. But some metal have a great tendency to do it. Some metal will less tends to behave like this. Then it will result with the differences in reactivities. Okay, and the last reaction, it is called displacement reaction. It is also a reaction of metal. It is the fourth reactions. So only four reactions we are concerned, but actually in our Form 6 series, metal, actually only four reactions. Okay, so don't think that, oh, there are so many reactions and we need to study so many reactions. We can't remember all of them. Only four categories of materials. We are talking about their chemical properties. And the first category, only four reactions only. Okay, we have with oxygen, water, acid, and the last one, displacement reactions. So we can say still many reactions we need to remember or we need to study, but not as much as we expect. Okay, I have told you that there are 40 million kind of material. If every material have its unique reaction, then there are more than maybe billions kind of reactions. But no, actually, most of the materials they behave similar. So we learn the main tendency, but maybe comparing their reactivities, we can study or we can expect or we can expect most of the reaction of most of the materials. Okay, and in this chapter, we will start to learn how to write down appropriate chemical equations. In the previous lesson, last two or three lessons, I've told you what is chemical equations. It is a representation of how reaction is going. Okay, that means, for example, if you still remember, I've told you that the oxide of metal can react with carbon to form the metal itself and carbon dioxide. But if we want to describe it in a sentence, it is too long. For chemistry, we want to just write down some symbol to represent the reactant and products. And don't want to write down is react with and to form such kind of wording which is not useful, okay, to represent a reactions. And also, I've missed one point too. The chemical equations, it is a unique representation of reactions that all the people in the world can understand. Because you know that you are studying chemistry in English, but some people they study chemistry in Chinese. If we try to describe reaction by English or Chinese, then the two kind of people they cannot understand the others. But when we write down the reaction in form of chemical equations, all the world, all the world they study chemistry, they can understand the reactions. So why we need to learn how to write down the equations, okay? And of course, not only write down the equations, we need to learn how to balance it. That means the number in front of each reactant and products, okay? Because it is very useful in calculations. After these chapters, we will start to learn the calculation in chemistry, okay? But I've told you, the calculation in chemistry is, I do think that it is very easy because it includes plus, minus, multiple, divide, divisions, and no other difficult calculation method. Okay, maybe very seldom you need to use quadratic equations to solve a equations, but very seldom, not quite. Usually, it will be asked in the examinations. Most of the questions they are just asking about plus, minus, multiplications and divisions only. Okay, so don't afraid. Although maybe some student they study chemistry, they always say that oh the calculation in chemistry is difficult. But remember, don't uh, don't hurt them or don't believe them. Okay, and writing down the equation sometimes or only 1 mark in out of the public exam questions, you are required to also write down the state symbol. You need to learn, but because there will be some marks, 1 to 2 marks at most. Okay, but if you think it is still quite difficult, you are not familiar with writing down the state symbol, maybe you lost 1 to 2 marks only. Okay, so don't be afraid of this. And also we need to talking about the displacement reaction. It is actually and the fourth kind of reactions. Okay, not only the displacement reactions, you need to describe and explain all of the four reactions that metal will undergo. Okay, what is described? Just write down the observations. In Form 1 and Form 2, you learn in science, we need to write down appropriate equation, observation of a reactions. Okay, of n reactions, or of a reactions. But actually, I can tell you there are only four different kind of observation only. Okay, if your the original reactant is such a situations, then you just write down the observation. You can expect the observations. Okay, I will teach you how to simply write down the observations of all the reactions. Describe means you write down the observations. Okay. In explaining the displacement reaction, okay, displacement reaction you need to explain, but all of the four reactions you need to explain. Okay, and deduce the order of reactivities. After you know that oh this reaction react vigorously, and the other vigorously means that the reaction react very fast. Okay, and the other react slowly. Then you can immediately tell me that which one is more reactive. The first one, right? So some kind of public exam question will ask like this. You will be given the observations and you are required to put them into the reactivity series. That means it is quite easy way of questions, okay? And after we learn the writing of chemical equation, we will try to simplify the chemical equation into ionic equations. Up to now, I will not fully tell you what is ionic equation. When we are talking about ionic equations, you will learn that ionic equation, some students at first, when they learn, they think it is difficult, but actually ionic equation are some simplified equation of the original chemical equations. Okay, you love it. I do love to write ionic equation instead of chemical equations because it is more simple. Okay, and feasibility of chemical reactions. After you learn the reactivities of different metals, okay, you can predict whether a metal will undergo the reaction or not. Okay, it is the feasibility. Okay, what we are going to learn in this chapter, it is the syllabus. Okay, let's start the main contents. For the first part, different reactivities of metal. It is easy to understand. Actually, metal, there are 87 kind of metal in the world. They are not the all. They will not be the same. If they are behave the same, they are the same things. Okay, but we try to uh, the human discover there are more than 80 something kind of metals. That means they are different things. Okay, so they react differently. So we usually describe it as they have different reactivities. Okay, uh, we are not going to write down the exact weight of reaction. So usually we will use some adverb to describe the reaction very fast or very slow. So you probably need to learn how to write down such adverb. Okay, one of the adverb is uh, violently. Violently. That means the reaction react very fast. Very fast. Okay. So if you're looking at the reaction itself, it reacts very fast. You can describe it. It react violently. Okay. And some will react very slow. Just write down slow. React slowly. The opposite is slowly. Okay, I don't require to explain what is slowly. Okay, just write down react slowly. And we will learn further adverb to describe reactions, but they are similar. For example, different from violently, you can also write down vigorously. Okay, later you will learn how to write down such things. Okay, and in the syllabus, we talk about we can predict when we after we learned the reactivities of different metals, we can predict the feasibility of reaction or predict their properties. Because we after we know that potassium, all the reaction are violently or explosively, then we can expect that the other reactions they will also react fastly. So it can also explain some of its properties. We have learned that in group one metal has a common properties. All the group one metal, although they are metal, they should have a very shiny appearance, right? Because metal should have a shiny appearance. But why? When we're looking at the potassium, usually it is dull. That means it is not shiny. Yes, not shiny. Why? Because it is too reactive. It reacts violently with anything if it will undergo reactions. When you put a metal potassium in the air, it will immediately react with the oxygens and become oxide of potassium. And oxide of potassium is not metal, it is an ionic compound. Become compound, the properties will different from the original element. The oxide of metal, usually they will not have shiny appearance. You can describe them as dull. Okay? So sometimes the public exam will ask you why the appearance of potassium is not shiny. Just explain it because it will immediately react with oxygen to become oxide. Okay? Within several seconds, it will turn down. Okay? So if you want to look at the real appearance of potassium, you need to freshly cut and look at it immediately. Maybe after 10 seconds, it will not shine again. Okay, but on the other hand, if a metal is very non-reactive, unreactive, they will not react with oxygen. Even you put it in oxygen for 1,000 years. Okay, So they will forever keep shiny appearance. One of the example is gold. And we flash back to the previous lesson. Why we use gold to make jewelry? Because it has a forever shiny appearance. Okay, and we love the shiny appearance. Okay, so we use gold as the jewelry. Okay, and why? Because it is so unreactive. It will not react with oxygen in the air. We will not react with water because when you wear a jewelry, you will have sweat, okay? And the sweat contain water, and water is a substance which will tend to react with many metals. But gold, the reaction is very slow, maybe after 10,000 years. Not only 1% of reactions will undergo. So the gold, no reaction, nearly no reaction. No reactions, you will keep the original appearance, okay? So why gold has such properties? And when we compare the appearance, we can conclude that potassium is more reactive than gold. So if we put them in the sequence, the series, we should put potassium higher position than gold. But of course, there are not only two kinds of metals. So we will fit the other metal in the series. But should we understand or should we study the 87 kind of metal? No. How many metal we need to study in the previous lesson? I've told you that the first one is potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, mercury, silver, gold, 12 kinds. Okay, if the other metal are being asked, you will be told that which position they should be fit in to the same reactivity series. Okay, maybe sometimes you will, according to the reaction, it is more vigorous, more faster than the other to try to put a new metal into the series to annul the series. Okay, but such kind of metal are not common. Most of the questions are talking about the 12 metals only. Okay. So how we put them into the series? We compare the reactions. But to be fair, in Form 1, you know that what is fair test, right? So when we are talking about reactions, we need to do some fair tests. Okay? But although all metal may undergo the same reactions, if you want to start the reaction, we may need to change the temperature. So it is not fair. We react the metal in different temperature. It is not fair. So sometimes we need to compare the reactivities by comparing the temperature start to react. Okay? For example, like reaction with water. Some metal we react with cold water. Okay? Some metal can only react with hot water. And some metal can only react with steam. So, which one is more reactive? Metal A can react with cold water. Yes. Metal B react with hot water. Metal C react with steam. Which one is more reactive? The one react with cold water. So actually, sometimes we need to compare the reaction of the starting temperature. Which temperature the reaction can undergo. Okay, so we can compare the temperature. The one with the lowest temperature and the reaction start, the metal is more reactive than the one require high temperature. The same, if you want to burn a metal, some metal can easily burn by a match. Okay, some you may need the Bunsen burner to heat it for maybe a minute to start the reaction. So the one which can burn with a match only, it is more reactive than the others. Okay. If we start the reaction in the same temperature, then we can compare the speed or the weight. How can we compare? We can measure the product they form. For example, they will give gas. We can measure the amount of gas in the same time of period. It is called the weight. Yes. In this chapter, you will learn some experimental setup. How can we collect the gas formed in a reactions? Okay, and you need to draw the experimental setup. I've told you that you need to draw quite a lot of different diagrams. Usually the diagram are the experimental setup. Some of the experimental setup you will not have the chance to set it up really, okay? But you need to know how to draw it. But I've told you the drawing should not do not require a very perfect drawing. But I suddenly think that it is too loose when I thinking about the previous test. I should remind all of you, although the drawing should not be do not require a perfect drawing, but don't draw it too ugly. Okay, sometimes the marker cannot understand what you are drawing. Okay, and also how the reaction give out heat energy. Actually, in the world, most reaction when they react, they will also give out heat energy. Okay, if a reaction react faster, they will give up more heat energy. Okay, so when you are comparing burning something, burning of fossil fuels or petroleum, do you think the weight is faster or burning of charcoal? Petroleum give out more, burning of petroleum give out more heat energy. That means the reaction of burning of petroleum is faster than burning of charcoal. Okay, so we can also compare it. But about the how can we compare the reactivities? Seldom asked, but maybe asked in MC. Maybe asked in MC only. And not quite high possibility to ask about how can we compare the reactivities, okay? And okay, then we start to learn the four reactions of metals. But I've told you only 12 different kind of metal we are concerned. And you may think that 12 metal and 4 reactions, that means there are 48 kind of reactions. Oh, so many things to remember. No, because not all the metal will undergo the 4 reactions. Some of the reactions, only half of them will take place. Okay, so there are only 37 kind of reactions. Okay, the first reaction is react with oxygen, react with air, or burning in air. The reaction, we can describe the reaction in many different ways. React with air, reaction with air, burning in air, react with oxygen. They are talking about the same thing. Okay? And you are not required to make the reactivity series by yourself. In the previous lesson, you learned the series, and some of the students actually remember the sequence already. So we directly go into how they different from each other, the reaction rate and the chemical equations. Okay, starting from potassium. Potassium is the most reactive in the 12 metal we need to study. So you can expect heating it with a match, we can start to burn it. Okay, but the other observations, actually the column in the middle are talking about the observations when you burn potassium in air. And you now start to learn how to write down the observation of a chemical reactions. Okay, it will start to burn. It is not the superoxide. Yes, I will teach you what is superoxide. Yes. Okay, it start to burn in a gentle heating. Maybe a match can make it start to burn. Okay, and how can you describe the reaction? I've told you that burn and then an adverb to describe the reactivities. You have already learned violently. And the second, similar to violently, is vigorously. Okay? also very fast. Which one should you remember? You should remember both, including the violency and also vigorously. Why? Because when you're looking at the question, it describes that the reaction react vigorously. You should know that very fast. Violency is very fast. But how can you describe the reaction by yourself? You may remember either one is okay. If you want to describe a reaction in a very fast way, you can write it burn vigorously or violently. Okay, they are also describing the reaction in a very fast way. Okay, and burning of metal, some metal will give a flame color. Still remember the flame test of potassium ion? Not purple. I always remind you, don't write purple, no marks. Lilac. And don't write down lilac fire. We describe the fire as flame.
LILAC, right?
Yes?
Yes.
Okay. It is the typical flame color for potassium and potassium ion. In the previous part, we learned the flame test. But based on the same theory, when you burn potassium, the potassium will become potassium ion. And the potassium ion in a flame, that means it is hot, just like when you test potassium ion. So it will give the same flame color because you are burning potassium and also try to test potassium. Okay, they are in the same environment, so they will give the same color of flame. It is the second observation. The first observation is you can describe reaction burn vigorously. The second observation, you can write down the flame color of burning of metals. But I would suggest to write down the second observations if you are required to describe the observation of the reactions. Okay? The first, you can describe the reaction, how fast is the reaction. The second, you can describe. There are two different points. The first point, you want to describe the reaction, you can describe it burn vigorously. The second point of the observation is it gives a linear flame. Okay? And the third one, for this reaction, no need to remember. Never ask because it is not included in our syllabus. Because potassium is too reactive, it will not form an ionic compound as our expectations. I could like to ask you, still remember the charge of potassium ion? Group 1, so the charge to be 1 plus. And what is the charge of oxide?
2 minus.
2 minus. So if potassium reacts with oxygen to form an ionic compound, the compound should be K2O. K2O, right?
Yeah, no.
But you can looking at the equations. It is not K2O. Okay? So you will not be asked. You will not be asked in public exam about the reaction of potassium burning in air. A normal public exam question. Why just talking about normal? It is because if you are being asked about the compound KO2, the question itself will give you some extra information. Maybe it will tell you that, potassium burns in oxygen to form a compound called KO2, and ask you some other questions. You will be given more extra information before you will be asked. And such kind of reaction are difficult reaction in public exam to test the student whether you can get five star. But the chance of asking such kind of question is very, very low. Okay, so you will be given because it is a real situations. And if you want to know why it will not give K2O, but instead KO2, why? It is because potassium is too reactive. Talking about it want to lose electrons. It's very easy to lose electron, and when it meet a O2, because it react with O2, it will immediately catch a O2 with it. It gives the electrons to the O2, and the O2 can have the chance of getting one electron only and become a O2 1 minus ion. very strange. But it is because the reactivity of potassium. But it is not included in the normal syllabus of Form 6 chemistry. So just have a look only, okay? No need to remember it in normal public exam questions. If it is being asked, extra information will be given in the questions. But the chance is very, very low. Okay? Many students will not know how to answer such kind of question. So you can write down that this reaction is no need to remember it. Okay? And potassium, iron do not have color. Oxide ion do not have color. If it form K2O, it should be a powder with a color of white. But you can see it has a color of orange. We will form a powder. And the compound it will always become a solid, okay, in room temperature and pressure. But potassium ion, no color. Oxide ion, no color. The ionic compound should also have no color, or in solid, it should be white. But you can see the real situation is it is orange, okay? You are not required to remember the color too. So for this uh, row, the most important thing is it will burn vigorously. It will give a linear color. The other information, no need to pay more attention or try to remember all of them. Okay. But starting from the second, it is very important. Every point, every items is important. Okay, sodium is also very reactive, but not as reactive as potassium, so it will not form superoxide. It will form normal oxide. So the normal oxide, sodium is 1 plus, oxygen is will become oxide and 2 minus. So the compound is Na2O, okay? And because it is very reactive, gentle heating is required to start the reactions. Okay? And if you are required to answer the observations, also you can describe the reaction as it burned vigorously. Then the second observation you can describe is it burned with a golden yellow flame. The same as the flame test, the color of flame test, because the same theory. Because you burn sodium, sodium will immediately turn into sodium ion, and it is very hot, just like the situation in flame test. So it will give the same flame color. Okay, and the third observation, it will form, it will produce, it will give out. You can write down produce. It will. You can also write down form or give out a white powder. So the three common observation, the 3 point is, if you burn something, you can describe the rate of reaction vigorously, gently, slowly. You can give out, if it give out any flame color, you can write down the flame color, it is the second point. And you can also describe the product form, the color and the state of the 冇八卦啦，好明顯走句都係八卦咯。出面塞住車啫嘛，塞車都要裝嘅，你哋真係。啊，sorry，Okay, you are also required, or you can also write down the product form, the outlook of the product. The outlook of the product, including the color of the product and the state of product. If it gives a gas, you just write down it gives a what color of gas. If it gives a liquid, you can just write down what is the color of the liquid. And if it gives a powder, a solid, just write down, oh, it gives a white solid or a powder. Yes, not only powder, you can also write down solid. Okay? And if you are asked to write down the observation nowadays in public exam, most probably you are required to write down one observation only. So, oh, should I remember all the point? No.
Yes.
No. Just remember, or if you cannot remember all of the observation, try to guess the most probably observations. For example, oh, a metal is burned in air. The most probably, oh, because I remember potassium, sodium, calcium, and copper will give some flame color. You can, oh, I forget the whole observations. Oh, but potassium burn in air because potassium burn in air will become potassium ion. So it should give a linear flame. So in examination, oh, I forget most of the contents in this page, but I can guess that potassium burn in air will give lead flame. Just write down it burn with a lead flame. Full marks, because you will only ask 1 mark of such kind of questions. Of course, some of the examination questions will ask you to write down all the observation, but the percentage is asking one observation only, maybe 80 something percent chance.
Wow.
Write down all the observation, just more than 10% of chance to answer like this.
即係得 potassium、sodium、calcium、magnesium 先有色嘅啫嘛。
係啊，咁如果係後面嗰啲咧，就可以 write down the solid form, the color of the solid form. They must form a solid because all of the product of burning of metal will give ionic compounds. And ionic compound in room temperature and pressure, after you burn it, it will turn back to room temperature and pressure. They must give a solid. They must give a powder. Okay? But some of them will have color. So just remember the color of the powder. Not all of them have a color. So just remember several of the oxide, metal oxide, the color only. You can very safe to get full marks. Okay?
1分入幾多？
Hey, for proper exam, 1 mark may
1000 grade
yes. Okay. So talking about the other point of importance, it is the weighting of equation. But maybe I will wait for all of your class coming back because you need to immediately practice. And I will give you some worksheets to write down all the equations, to practice all the equations you are required to learn in this chapter. Okay? Okay. So in this lesson, I will try to concentrate on what is the observation first. Okay. And the third metal we are going to study is calcium. Try not to looking at the observation. Can you give the observation when calcium is burned in air? If you are only asked for 1 mark, don't write down the observation is it gives calcium oxide. Remember, observation is what you can see and how can you describe what you can see. You cannot see that, oh, calcium burn in air to form calcium oxide. You can just see the white powder form. How can you see the white powder is calcium oxide? You cannot use your eye. You are not X-ray eye. You cannot, oh, looking at the white powder, it is calcium oxide. It is not observation. It is guess only. So,
咁你咪話講係
will it burn vigorously in gentle heating?
no 因為佢話 strong heating 先得講。
No, no, no. Because the reactivity is in the third position, it will still burn very fast. Or burn it in strong heating, it will immediately burn. So it is not a good observation. But can you guess the flame color? Calcium will burn in a what kind of flame color? Brick red flame. So you get full marks. If the examination, the first term examination, oh, can you write down the observation when calcium is burned in Bunsen burner? You can, okay, 1 mark, then just write down it burned with a brick red flame. Full marks. Oh, at that moment you forget the flame color of calcium ion. Then you can expect that it will form a powder or a liquid or a gas. Should be powder because it will give an ionic compound. What is the color of the calcium oxide, the powder? The color must be, remember, for ionic compound, you can expect the color by separately looking at the ion. Calcium ion have any color or not? Remember, you just learned 10 iron with color. Calcium ion included in the 10 or not? No. Calcium ion is not included in the 10 metal ion. Yes. It is not included in that table. Then it must not have any color. Oxide? Should it has any color? No. Two no color ion combined together. But for a solid, we cannot describe it as colorless solid. Because, yes. So you can expect the product is white powder. Okay? So if you forget the flame color of calcium
即係一
oxide,
係搭 flame colour，一係搭個
yes,
outcome。
the solid, the color of the solid
即
form.
係如果我搭 either one 都攞5分。
Because you are just required to write down one observation only.
哦。
One marks is given, so of course one observation. Don't write down two observations because you are not following the instruction of the questions. Looking at the observation, usually the question will ask you to write down one capital letter for one. It reminds you that you must only write down one observation, don't write down two. Okay? Okay, the third one. The fourth one. The fourth one is magnesium. Actually, potassium, sodium, calcium, magnesium, and these four metals, you will have the chance to burn it by yourself. But not all the students. You will be select. Because I don't want to burn so many potassium. Actually, the observation is the same. So maybe drawing from your group, you can go out to hold the metal, not by your finger, of course, by tongs, pair of tongs. Hold it and burn it in the Bunsen burner, maybe next week, okay? To try to see the observation. Does it burn in gently, the flame color? And can you see the product form?
No. I mean the powder.
Can you looking at the color of the powder?
Yeah.
You by yourself. Okay, next week you will do the following reactions. Tired? Okay, but actually the lesson will be end in 10 minutes. So let's continue.
Thank you. Yeah.
Okay, the fourth reactions. I do think that maybe your IS teacher have to show you this magnesium, burning of magnesium ribbon. Usually in the laboratory, magnesium is not a solid lamp, not a piece, but it is making into a ribbon, magnesium ribbon. Yes. So the observation. What's happened? Okay. There are some announcements. To remind you that after this lesson, you should go back to your homeroom. Okay. But it's not. So I continue.
Good afternoon, principal, teachers, and students. Sorry to interrupt your lesson.
So let's end in
Because
this
of
part.
the special arrangement.